Now that we're more familiar with properties of the graph of a hyperbola, now we're going to work backwards where we're given the properties of the graph and we're going to come up with the formula or the equation of the hyperbola in standard form. So in example 1, it says that we have a center for the hyperbola at 0, 0. And we have one vertex at 3, 0. And by symmetry, the other vertex would have to be at negative 3, 0. And we have one of the focus points is at 5, 0. So the other one by symmetry would have to be at negative 5, 0. What this tells us is that the transverse axis is running horizontally. So when we write our equation, our x squared term needs to be first. Also, what this tells us is because the center is at 0, 0, our equation in standard form is going to look like this. So what we need to do is figure out what our a and b values are so that we can put this equation in standard form. Now we already know what our a value is because our a value is the distance from the center to each vertex. So I know that a is 3. We also know that the focus is 5 units out from the center. So I know that c is 5. So using our equation, c squared is equal to a squared plus b squared, I can derive that b is going to be 4 using c squared is equal to a squared plus b squared. So my final equation for this hyperbola with these properties in standard form would be x squared over 3 squared minus y squared over 4 squared is equal to 1. For the next example, we're given properties that we have focus points at 0, 6, which would be up here, and 0, negative 6, which would be down here. By symmetry, I would know that my center has to be at 0, 0. This also tells me that the transverse axis runs vertically. This also tells me that my value of c, because this is my focus point, and my focus point is a distance of c from the center, this tells me that my c is 6. The other information that's given to us is that c over a is equal to 3/2. Well, if c is 6, then a would have to be 4, because if I would have 6 over 4, that would reduce as 3/2. So now I know that a is 4, c is 6, and then I can use c squared is equal to a squared plus b squared to find out what my value of b is. So if I plug in 6 for c, that gives me 36, because c squared, that's 6 squared is 36. And then a squared would be 4 squared, which is 16. And when I solve that for b, I'm going to get that b is the square root of 20. Now, because my transverse axis is vertical and I have a center at 0, 0, I know that my hyperbola in standard form should look like this. I know what my a and b values are, so I'm going to go ahead and plug those into our equation. And I'm going to get y squared over 4 squared minus x squared over the square root of 20 squared is equal to 1. And this would be our final equation for a hyperbola with these properties in standard form. Okay, last example, now we're looking at the graph. So we have to pull the major features from the graph. When I look at this, my center is going to be where my asymptotes cross. So my center is going to be at -1, -2. If I imagine that I draw my box, I can see that my value of B is 3 because from the center out would be my value of B. My value of A would be my center out to the vertice. So that's going to be A is 4. And if I use my equation C squared is equal to A squared plus B squared, I'm going to find that C is 5. My transverse axis is running vertically, which means my y squared needs to come first. However, this is also a shifted hyperbola, so when I write my final equation, it's going to look like this. And I've got to plug in my values for h, k, a, and b. Here's my h and here's my k. So I have y minus a -2, so that's going to give me a y plus 2 because it's a double negative. A is 4, so it's going to be 4 squared minus. My h is -1, so I have x minus a -1, so that gives me x plus 1 because of a double negative, squared over b, which is 3. So I have 3 squared is equal to 1. So here is my final equation for the graph of this hyperbola that has been shifted with a center of -1, -2, and it's in standard form.